but I'm hitting live.
Oh,
We
we're
should
live.
be live. I'm going to make sure we are before we really get into stuff.
I see the little live logo.
Yeah. And cool. YouTube is going. LinkedIn is going. And if people are already here, joined in, say hello in the chat. It's always fun to kind of see where people are watching from at the bare minimum. If you want to say hello or maybe where you're watching from. I'm streaming from Seattle, Washington. Yujian, are you as well?
I'm also streaming from Seattle, Washington. Yes, indeed.
Well, I never know. You travel a fair amount sometimes, so you could have been in the Bay Area, and I wouldn't have been surprised.
Yes. Every so often, I am also gone from Seattle. I think I'll be here until early February at least.
Nice. A lot of well, there's a lot of cool stuff going on around here, and I mean, you're running some of it, so we can shout those out later as well. But actually, I don't think I have it in the note yet. I'll add it in later. So if you're watching this later, there's a meetup happening next week that Zilliz is sponsoring. That's going to be really fun over in Redmond. I believe it's at Microsoft Reactor.
It's at the Microsoft Reactor. Love that venue. They're very easy to work with. My only complaint is I live 45 minutes away.
Yeah. I'm also on the west side of Seattle, so sometimes going to Redmond's a little bit of a trek, but it's not too bad. It's great. I'm happy that I'm around in the area and can go to those things.
Yeah. I think I'm thinking I should just show up to these I should just drive over at 2 p.m. and then hang out and just hang around until 5, and then I don't have to deal with
That's often what I do if I don't have a ton of meetings. I find a cool cafe to work out of, and then I'll go to a meetup, and you kind of bypass some of the traffic, and I don't know. It's nice to get there early and hang out.
Yeah.
All right, so we got people in. It looks like we're streaming everywhere, and I'll just do a quick intro before we get into the topic. So my name is Sage Elliott. I'm going to be the host of today's Fireside Chat. And our topic today is the essential role of vector databases in LLMOps. We have our guest Yujian here. And before we get started in the conversation, I'll just also shout out if you are working on something interesting, especially around the MLOps space or machine learning, and you want to come on and give a fireside chat like this, it's around a 30-minute plus commitment, usually goes over a little bit. Reach out to me on LinkedIn or our Flight Community Slack, which is in the description below as well. And then also, I'll just quickly shout out, we have a swag/giveaway raffle going on right now. So I'm going to post the link in the comments, and you can have a couple different ways to enter and win some cool stuff. So with that, I'm going to go ahead and get into our conversation today. Thank you so much for coming on, Yujian. It's always a pleasure working with you and listening to you talk about vector databases. You're definitely the person that I know of that knows the most about them, and you always answer questions really well. So I'm really excited to have you here. So also shout out again, if you're watching, say hello in the chat, maybe where you're watching from, and feel free to ask questions in there. Hopefully we can get to them. We may not get to all of them depending on timing. But before we get into vector databases, could you provide an introduction and let us know a little bit about your background and maybe a little bit about what you're currently working on?
Yeah. Thanks for having me, Sage. I always love doing these streams with you. You always make things really, really nice, really easy, and I always feel really prepared for these. So, So my background mostly, So I did a lot of contests, kind of stuff, and that was actually how I got into software engineering. I won some computer science contests. I did some research on machine learning in college. I did a bunch of research on computer vision and data integrity, and then I worked on the AutoML system at Amazon for a while before getting into startups. I really enjoy just what's working on the cutting edge and all the really cool AI stuff that I get to work on now. So I've been at Zilliz since April of last year. And since then, I've been building a bunch of apps on top of vector databases. And most of these apps happen to be LLM apps. And most of those LLM apps happen to be RAG.
And what is RAG? I know we'll probably get more into this later, but just in case people don't know what it is.
Yes. Retrieval augmented generation. And so actually I called someone, I had a phone call with someone in December, and they were telling me that there's like both like RAG and the opposite, which is like GAR, I think, like generation augmented retrieval or something like that. And like the difference between these is like in the order in which you're using like the LLM. So like one is like, so what is it? RAG is retrieval augmented generation. So what that means is you go and you retrieve stuff from the vector database before you send it to the LLM, and then you generate something. And then the other one is you generate something and then you go retrieve something from the vector base based on what you're generating, which I assume is more like something like if you're going to take like maybe it's like you're playing Jeopardy. I don't know. Like you take an answer and you're like, give me the question, and then you go and you have a vector database full of questions and you pull those out or something like that.
Interesting. Yeah, I hadn't heard of it, I guess, called GAR before, but it makes sense.
Me neither. Yeah, someone was saying this, and I looked in the repo, and I was like, her name is eluding me at this moment, but the project that she works on is this thing called Tiger Labs, and so I was looking at the repo, and there's this thing in there called GAR, and I was like, well, what is GAR? You know,
I'm pretty sure that's a type of fish as well. I could be wrong. All right. So our main topic today is the essential role of vector databases in LLMOps. Before we get into the, I guess, more of the vector database part, maybe we can talk a little bit about what LLMOps is. So if you could describe maybe what is LLMOps?
Yeah, I think like, you know, over like the last few years, we had the whole like influx, I don't know, like a rise of MLOps companies, and with the introduction of GPT, basically LLMs, we now have this kind of like we already know that we need MLOps for when we do ML in production, and now introducing this new class of model, I suppose. Like, I don't really know if I would call them new types of models, but new class of models, like these large language models. We know that, oh, we actually have to do these in production too. We have to, have ops around these, basically, kind of like DevOps, ML ops, info ops, whatever. But one of the things that is like different from like the LLM ops stuff, from the ML ops stuff, is you're not really like looking at, how is this the steps to training the model and hosting it and running inference on it, but it's more like, okay, like you have to take care of some of that stuff as well. But you also think about things like, how is my model performing in production? Because the focus with LLMs is really that they allow you to kind of do these new interesting applications that you weren't able to do before.
Yeah, and it's interesting. It's almost harder than a lot of other ML applications to like evaluate performance in production and then keep improving that. And so now we have things like, and there's other pieces that also, like you said, this ties into a lot of other ML applications too. But you have things like not only your training and retraining, which you probably do if you're hosting your own model, not if you're probably using an off-the-shelf API,
right?
But you might be like you'll want to tie things together. Like we'll talk more about how vector databases are used in it, but that's usually a pretty big piece of a lot of applications right now. And same with prompt engineering, and then also how do you measure, like, is that prompt engineering or that prompt that you changed affecting your model in a positive way and doing the things you want? It's a very interesting problem right now. There's all these different tools that we can tie together, and the LLMOps piece is like, depends on what your application is, but tying these different tools together. And usually a big part of that is like ensuring your model's doing the thing you want and then changing things over time to probably make it better over time.
Yeah. A lot of it is like changing, like not just like the prompts and stuff, but also like your little configurations of how you're using it. So like I don't know if this is like, I can't remember if this is a question that's going to come up later, but like, for example, like one of the things that we do with vector databases is like the whole like chunking and embedding and like the pre-processing your data. And like that is like something that you have to tune as part of your whole like LLM ops thing in your LLM stack.
Yeah, makes a lot of sense. All right, so before we go into, I guess, tying it even more into the LLM application, what is a vector database? And I think you always have a really good explanation of this. I've seen different variations of your answers in different talks in the past. Sometimes you use Taylor Swift as an example. Sometimes you use something else. But for people who don't know, what is a vector database? And maybe, how is it different from a regular database?
Yeah. Geez, I wish I had my visual of Taylor Swift. I think it's a fun visual. It gives people the exercise of being a vector database themselves. But a vector database is essentially different from the regular databases in the way that it operates and the data that it operates on. So vectors are a series of numbers, and vector databases are built to to operate on these series of numbers, to do computes, to find the closest other series of numbers. And most of the time when we work with vector databases, these vectors that we're working on are vector embeddings. And vector embeddings are the numerical representation of the meaning behind the input data into a specific model. And embeddings models, which we'll probably hear a lot about, especially when it comes to RAG, embeddings models are the models that produce these vector embeddings. And so the way they work is you train your model to do something, and typically a model does some sort of prediction or some sort of classification, and that's what the last layer does. Let's say you're like the very classic example is like the MNIST data set, right? Like these are a bunch of numbers 0 to 9, and the last layer, what it is it's 10 neurons, it's 10 outputs, whatever, and just the highest probability one is the one that you get as your response. And so if you were to get the vector embedding from this, what you do is you would remove that layer, and then you would get the output from the second to last layer, and that would be your vector embedding. And the reason we take that is because as input comes through a network, each layer of the network learns something new about the input, and the last layer contains all of that information. And so that's kind of what the vector is, and that's the data that the vector databases operate on. And the main kind of difference when you think about why would I want like a specific kind of database or a specific kind of database architecture or setup to do this is if you think about the way we currently work with data, SQL databases, NoSQL databases alike, is really we're doing a lot of key-to-key matching, right? When you're doing a SQL database, you're selecting something from some table where some set of parameters match. And so you're optimizing for this ability to do a key-to-key match and do basically entity relationship modeling on the fly. And with NoSQL databases, what you want to say, I don't know, or what you essentially are doing is you're saying like, I don't know what attributes these entries may have, but I can kind of map all these entries to these IDs, and I can allow a flexible attribute schema. And so NoSQL databases are also optimizing for this ability to do key-to-key matching. So when it comes to vectors, you're doing a bunch of computations, because the only way that you can evaluate how far vectors are in space is by doing a bunch of computations. And nothing that implements key-to-key matching is optimized to do these kinds of computationally expensive tasks.
Yeah, and what would be an example of, like, I like the MNIST example. What would be maybe an example with language of, like what would a vector look like between maybe two words? I think is a good example of kind of showing people, like, I think often when it comes up in books is like, queen and king, and kind of a certain distance from each other. And so that there's like a distance number because, queen and king are different words, but they're associated with, a position and royalty or something. And so they have like a space between them where it's, relatively small. And then versus, I don't know, what would be something completely different, like a potato. A potato is not a king or queen. It's not a person. It's not a position. And that number, if that's a distance between like how related it is, the number that between a potato and a king would be probably very large, right?
Yes. Yeah. That's also one of my favorite visual examples to show.
Potatoes?
The whole like king, queen.
I know, I'm just kidding.
We could start using sweet potatoes instead. Sweet potato, like yam, regular potato. I don't know what other kind of.
I kind of like that actually. I might use food groups. I feel like food groups would be a fun example between relations.
Yes, and I feel like it might even cause more debate in the audience too. People have strong opinions about whether or not food belong in certain groups.
Yeah, that is, how far is hot dog from a sandwich? That's a good question for a vector database to answer.
Oh my God, what if we get into the whole like, is a hot dog a taco thing?
Yeah,
This is going to be what's
this
going to
will
happen.
be a fun different talk we can give at some point maybe. But yeah, I like tying it back into here. I think the example between like words, and so you're kind of storing like that distance in between those words is like a vector space, and you're storing those in a vector database, which is optimized to kind of return and search that very fast, correct?
Right.
Versus using like a more traditional SQL database.
Right. So if like so the usual like text, I guess, like natural language example that I give for this is like, let's say you have a report about a company. You know, you're going to have like the words like profit, bottom line, profitability, and these are all the same words. And if you were to use a keyword search, you would have to go through 3 different keyword searches to find them. Or if you are using an NLP powered keyword search, maybe you only have to do 2. You can limitize profit. But with vector search, then the idea is that because you can just say like, oh, profit, I know that in vector space, profit, profitability, and like bottom line are all basically right next to each other. I can just pull all of these back.
Yeah, that makes a lot of sense. So this is perfect segue into our next question now. So why are vector databases essential for so many LM applications? And we've kind of touched on this a little bit, I think, in some of our other questions here, but can you dive a little deeper into how they're used and why it's important, and like why so many people use them? Maybe give an example of how it adds value to an LLM.
Yeah. So the whole not the whole, I guess, the main use case that we've seen for vector databases in LLMs, in LLM apps recently, is the retrieval augmented generation use case, RAG. And most of the time that's in the form of a chatbot. And so what vector databases do is like, let's say you have an LLM, and your LLM is able to take data and take text and format it and give it to you in a human readable response. And a lot of these like, cool fancy features, but it still doesn't have access to your data. So one of the, I guess, the primary use case for using an LLM in that stack is that, or sorry, using a vector database in that stack is that vector databases can give LLMs this kind of like new knowledge on your data. If you take your data, you vectorize it, you put it into a vector database, LLMs can take their query, their text query, vectorize that and use similarity search, or maybe they vectorize like some part of the query or something like something like that, and they you can use vector database to do similarity search to get back all of the information that you have that is most similar to whatever it is that you need to query about. So that's the use case for vector databases with LLM apps at the moment. That's like the primary use case.
Could you give an example of like if someone is, I don't know, maybe they're querying an LM for a chatbot, or they're querying a chatbot and they're asking a question around how do I use a vector database or something like that. And there is a vector database involved that gets that query, and they're going to look for similar questions or similar information. So you could store, I guess, maybe you can store previous questions and answers in the vector database. You could also just store a lot of documentation. And when someone asks that question, it's going to look at these documents and say, well, this seems like the most similar document or the most useful one for this type of question. I'm now going to bring in this information from that document to the LLM. So like right now, people have probably used ChatGPT, even if they haven't used a lot of other LLMs, you're basically how ChatGPT works right now. When you're asking questions to it, and it kind of has a history of what you've asked, so it knows context around what you're talking about. That's basically just storing your whole text history there, and it kind of has context because it's like it kind of becomes part of the prompt now. And that's kind of what's happening here with the vector database, right? You're just bringing in this external information. You say, here's a lot of context that maybe you didn't have before, and we think it's going to be helpful for you to answer this question. Now it's going to have that, and then it's going to generate an answer, but with this extra content that it was able to retrieve very fast from a vector database.
Yes, that is pretty much absolutely correct on exactly how that works. I guess there could be some interesting things to do with that. For example, when you were talking about saving the questions, the answers, that's why we created this thing called GPT cache, which is like a semantic cache that allows you to kind of like you would hit the cache before you go and look at the LLM, right? So there are like kind of methods that people are doing around doing things exactly like that. But I think like the most basic way to think about it is like if you were to ask what is a vector database and you have a vector database full of documents, then your LLM would say, okay, usage vector database, pulls it, and then does exactly what you just said, which is question, answer with this context, blah. And then it'll format it human readably and send it back.
Very cool. And it's funny because this is a question I asked in our last fireside chat, and I don't think it's a question that's going to be asked in many more of them, but we've mentioned RAG a few times. Yes. And yes. If you're working in the space, you probably see it come up all the time. Something we see coming up now a lot is multimodal RAG. And I was wondering if you could answer or touch on what is multimodal RAG?
Yeah, so I think, like, as far as I can tell, there's no industry agreement on what multimodal RAG is. But I think that there are many ways you can implement something and it would be multimodal RAG. And so some of these ways, and this is basically what I'm going to be working on, or at least what I would like to be working on this quarter, include things like, let's say you have images and text, and maybe your images are like a scene of, we'll just take, let's say you're making a chat app about Seattle. You have images of Seattle. You've got, I forgot what it was called. Oh, the Space Needle. You've got like the Space Needle, and you've got like, Lake Union and a bunch of other different things. And then you also have text descriptions of Seattle. A multimodal RAG app for this would allow you to search the images as well as the text description. So maybe the text description is like the history of Seattle and the images are like the landmarks. And the way that it would do that, the most basic way to do that is to have another model generate descriptions of the images and save those texts and embed and save those texts as the vector embeddings, and then include a link to the image inside of your entry. And then when you are searching, you can say like, I want to, show me some landmarks in Seattle or whatever. And it'll be like, here's a picture of the Space Needle or something like that. So that would be an example of like the most basic form of multimodal RAG. Other like versions of that would include things like maybe you have images and videos and you have a certain image and you want to see if it's in some videos, or maybe you have videos and you want to search other videos, or maybe you have images and you want to search through images and text, and your text descriptions generate images and you want to like find the closest text or the closest images, or just things like that would be examples of what multimodal RAG is.
Is it almost like you're combining different vector spaces together? So you have, in this case, images and text, and you have the Space Needle and a really good description of it. And then let's say you take your own photo of the Space Needle and you're, doing some sort of search for that photo, saying like, hey, like what is in this? And instead of just having like a very basic concept of captioning of saying like, well, it's a building, or it's a tall building or whatever, it's actually going to query some vector database, say, hey, this image is actually pretty similar to these other ones we have in here. And associated with those, we have all these other context around it. So we can actually pull in, instead of just saying, it's a building, we could say, oh, this looks like it's the Space Needle. It's located here in Seattle, and it can actually give a detailed description around it.
That would be one way that you could implement something, and it would be like a version of multimodal RAG. In terms of like the vector space thing, so there are ways to include. So I don't know if this is offered in Milvus yet. Zilliz offers a way to include multiple like vector spaces now. Might not be GA yet, but it will be coming if it's not released yet. But you can do like dense, sparse vectors, multiple vectors, and things like that. Actually, yeah, I'm pretty sure this was released. And like that's one way to think about it, but I wouldn't say it's like combining vector spaces. It's more like you're it like offers you the ability to search multiple different vector spaces. And then in the example that I gave of taking an image and turning it into a text and using that as a vector, then what you're actually doing is you're more or less mapping vector spaces, right? So you have the vector spaces, the images, but what you're actually using is the text description. And so you're trying to create this mapping. And actually, one of the challenges with this is you're never going to get a one-to-one mapping. And part of the reason for this is just like, like there's generation involved, and that's, you know, statistics, right? We're already kind of messing with some probabilities. And then like B, you would have to do like the only, I think, well, I hope I don't say anything that's like mathematically impossible here, but I think like the only way you can actually get that to do like a one-to-one mapping is something that is non-deterministic, right? So you would have to use like not a machine learning model to do that. But also like the challenge with this, like, I guess, concept of combining vector spaces is that you can only compare vectors of the same length. And typically, image models and text models have different length vector outputs. So I have actually heard of some people saying that they just like literally just tack them onto each other and just like do vector search that way. I haven't heard anything about these results, but I've heard that people have tried it.
That's interesting. Yeah, I think when I said combining, I probably meant mapping. but that's super interesting too, actually, that's like a thing.
Yeah.
And I guess you could add space between, or tokens or whatever, to your vector and tack them on. That's interesting. Yeah, I'd actually have to look at like a paper and see how that works.
Yeah.
So you've been building some really cool projects with LLMs. Could you tell us a little bit about your development stack around LLMs or LLMOps? I know like you bring in at least vector databases a lot of the time, maybe some other tools, like any other like models or tools or libraries that you're kind of enjoying and that you suggest other people look into if they want to build some sort of LLM application, even if it's kind of for themselves, or maybe they want to put something in production?
Yeah. So strangely, Milvus is like one of those like tools. It's like aimed at like enterprise grade, like all this kind of like stuff. It's like aimed at that. And most of the tools in the LLM stack are not. Most of the tools in the LLM stack are pretty new, and like most of the fun ones anyway, like, you know, LangChain and Llama Index. I really enjoyed using those. That's mostly what I use, and then I use a lot of Hugging Face. Hugging Face has a lot of different models for embeddings models. You know, it's got the mini LM models, and it's also got like a bunch of other open source. Like, yeah, I think even LLMs are on there now. I think Deci has an LLM on there. AI Blocks has quite a few LLMs on there. So that's one of my that's my main LLM testing. Most of what I've been doing is like playing around with LLMs and models. Other like parts of the LLM stack that I think that, you know, especially if you're going to go into production, that you need to use are like eval tools, right? We can give a shout out to Y Labs here, right? Arise, you know, Truera, and then for, you know, orchestrating and building more machine learning model stuff, you would use Flight.
Yeah, and I totally forgot to even include a blurb at the intro here that I work at Union, which is where this fireside chat is run, and we help maintain the open source project called Flight, which you can check out on GitHub, which is around orchestration, and you can kind of, you know, help tie all these tools together, make sure your application can scale. It's built with a Kubernetes backend, and then at Uni we also offer a managed solution of that. But back to Yujian as well. I included a link. I think there's links to most of the stuff around Zilliz and Milvus in the description if you're watching this, but I also just put it in chat. You can check out the GitHub link for Milvus. And as someone who has GitHub repos, their work, I know that they always appreciate a star. So give Milvus a star for being always an awesome open source.
All the open source projects are always like, give us stars. We need them.
I don't know. Stars are fun. Yeah, so check out the open source project, or open source vector database Milvus, which is awesome. I keep seeing like I mean, it has a ton of stars. A lot of people use it. It's production ready, like you mentioned.
Yeah.
Not even just something that you can play around with. Like if you're looking for a vector database to bring into production, that's one you can definitely go look at and bring in.
Yeah. Salesforce, Walmart, eBay got some big use cases.
Yeah. Awesome. And you mentioned, Hugging Face is amazing. I feel like they have most of the models right now. I think even Llama 2, I believe you can at least run in Hugging Face. That's my go-to place if I'm not using OpenAI's API, or if you want to fine-tune your own model and host it somewhere. I think even recently, I think just this week, Microsoft's Phi 2, which is the really small LM that you can fine-tune, I believe is on there as well.
Oh, dude. Okay. So recently I've also heard this thing like small language models, and I'm just like, okay, 1 to 7 billion people are now calling small language models. And I was like, that's pretty big still, actually. Like, wasn't GPT-2 like less than that?
Yeah, large language model. And now they're so big that people are saying the smaller ones, which were the original large language models, are the small one. That is kind of funny because I think Phi 2, I think is 2 billion parameters or something. And the Decis is like 7 billion. So if you are looking for some cool small ones, you should go check those out too and see if they are right for your use case.
Oh, I also just tried out one from Symbol.ai. I think they're also, I don't know if they're based in Seattle, but at least they have some people in Seattle. And so one of their guys was like, hey, we have this new LLM, you should check it out. And I was like, all right, we'll give it a go.
Well, yeah, I think they are based here. I could be wrong. I know at least some of their leadership is around in Seattle.
Oh, cool.
All right. So we've talked a little bit about Milvus, and you mentioned Zilliz and stuff. Can you tell us more about what Zilliz is doing?
With concerns to Milvus, or just like at a general like level?
Maybe a general level. I mean, you could talk more about Milvus if you want, but also, Zilliz is the company behind Milvus, and I think you're building more than just the database. So you can mention both if you want, or dive deeper into a project at Zilliz that you're really excited about.
Okay, cool. So what is Zilliz doing? Obviously, we maintain Milvus. This is our main project. Milvus is our open source vector database. So Milvus is on 2.4 now, I think. But outside of maintaining Milvus, we obviously commercialize Milvus since we are a company. And so Zilliz is the cloud managed version of Milvus, and it's like hardware optimized. And we do a bunch of like benchmarks around all this stuff. We do a lot of events. So we do like the unstructured data event that we're going to be talking at next week, which we have in both SF and Seattle. And I really want to get that going in New York as well. That would be really nice. Let's see, what else are we doing? We also have a bunch of other projects that we have worked on. So for example, like earlier I mentioned GPT Cache. GPT Cache is actually like really popular, and in terms of like downloads, which is really surprising because we don't really talk about it. We don't really do anything with it. But it is like it's a semantic cache, and I think it's one of the only semantic caches that are out there. And basically we created it because we were running up a huge OpenAI bill, and we were like, let's not do that.
Can you just touch on a little bit of like what that is, like why people would use it?
Yes. So let's say you have a public facing application. So in our case, we have this thing called OSS Chat. It's like OSSChat.io. Yes, it is OSSChat.io. And if you get a lot of questions, and many of these questions are frequently asked and very similar, then it does you a lot of good to not have to ping the LLM to answer the questions every time. It does you a lot of good to save the questions and basically have them in some sort of LRU type cache. And since we are a vector database company, we used Milvus as our semantic cache so that we can save the semantic values of the queries and not just the keywords. And so this allows us to basically filter out a lot of the frequently asked questions, which we also asked a lot of ourselves when we were testing. And so instead of paying, thousands, I think it was actually like tens of thousands of dollars in OpenAI bills every month, we got this down to like under 10,000. I'm actually pretty sure this was like, I'm actually pretty sure it's only like a few hundred. I think it's like actually like pretty low now. Yeah, basically it's a cost optimization tool, which is probably why it's popular.
So you're basically storing responses as a cache, and then when someone's asking that same question, you can just pull from that cache that answer.
Mm-hmm. Yeah.
You don't have to query an API or your model.
Yep. So like maybe a lot of people suddenly want to learn about, how do I build neural networks in PyTorch, and you've got 100 people asking the same question. Well, they're probably going to ask you slightly differently every time, the different capitalization, maybe different spacing, maybe different words, maybe different wording, et cetera, et cetera. But because, you have a cache with the vector database with the vector search, the semantic search there, you essentially have this, it doesn't matter if they're all worded differently, you can still get the same response back.
Awesome. That makes a lot of sense. That sounds like a great feature. I totally get why it's popular.
Yeah. And then the other thing that we've been working on is pipelines. So we just released pipelines, which is available to people who are using Zilliz Cloud's free tier. So Zilliz Cloud has a free, as long as we are in operation tier. And we added pipelines into it so people can easily kind of get started with piping their data into vector databases. Because this was like one of the biggest questions I got last year was just like, how do I get my data into a vector database? Can I just give the vector database my data? People were like, I'm sending JSONs to the vector database, but it's not working because of something. And it's like, oh, well, you need to vectorize the data. And then people are like, oh, how do I vectorize the data? And so pipelines makes that so that people can achieve this, I'm just going to give you some data, okay, go vectorize it for me kind of thing.
Cool. That makes a lot of sense. All right. So one last question here is I like to ask every guest, what are you looking forward to in the AI field that maybe isn't vector database related? I mean, I guess you could use a vector database to build it, but what is something else you're like excited about right now in the industry?
I think there's a few things I'm excited about. So one is I'm really excited about this kind of like blow up of more open source projects. I've always been a fan of this kind of like kind of grassroots bottom up kind of movement type of setup. And I think that open source is really good for that. And I also think I'm also very happy to see more interest in the AI community. A lot of that interest is coming from Web3, so that's an interesting thing to note. So yeah, I'm really excited to see a bunch of that, and then very far off into the future, just can't wait for the singularity.
And before that, maybe like a robot that can do like dishes or something like that.
Yeah, maybe like oh my god, wow, a robot that could do dishes, that would be real nice, and put them away.
Oh yeah, I shared. So someone asked about sharing links that you mentioned. I shared some. I think they went into the YouTube chat, not the LinkedIn one. And I will, after this, we're going to wrap up here soon. I'll make sure the links that I shared in YouTube, I'll put them in the LinkedIn stream as well. So if you commented on it, whoever asked that, I'll put them in a little bit later, and you can go click on those links to Milvis and the meetup and stuff like that. Awesome. Thank you so much for coming on. It's always a pleasure having you around and answer questions around vector databases. Is there anything else you want to shout out before you leave? I think we've already kind of covered some of the upcoming events and stuff. Anything else you want to give a quick shout out for?
Yeah, I'm just waving to Mert in the audience. Hi, Mert.
Shout out to Mert.
One more thing to shout out. I'm going to be hosting a hackathon series this year. First one is going to be January 27th. Not everything is set up for it yet, which is why it isn't announced. So this is your pre-announcement announcement.
Very cool. And when you have that announced, let me know. And I can also include a link in the show notes for anyone who's coming back and watching this later. So with that, I think we'll go ahead and wrap it up. Thank you again, Yujian, for coming on. Thank you again for everyone who came and listened and anyone who asked questions. And I'll make sure I update the description and LinkedIn comments with some of the links that may have been missed before. So with that, I'm going to go ahead and end the stream. Check out our community in the description as well. So if you want to come join the Flight community, it's kind of a general MLOps Slack that you can join. And I'm also been hosting a book club, which right now we're reading Designing Machine Learning Systems and meeting weekly on that. So if that's interesting to you, check out again the community link in the description as well. But that, I'm going to go ahead and hit end stream. It might take a minute to actually wrap up here.
Cool. Thanks.